Hey guys, so I had some requests for number 1, 4, and 5. So here we go. Number 1, we are going to see, well, I guess I need my equation editor. There we go. All right, so number 1, we see that we need to pull the negative 16m and the negative 21 to the left side of the equation. And so in doing that, we make both of these positive. And so we get 3m squared plus 16m plus 21, and then that equals 0. And then from there, we multiply the first and the last term, and so two numbers that multiply to be 63 and add to 16, that's 7 and 9. And so there we see 3m squared, and I'm going to put the 9 first because 9 and 3 have a greatest common factor. And then so do 7 and 21. Okay. And then the next line, we would group this, and we would get, when we group these, we would get 3m, m plus 3 for the GCF in that first one, plus 7, m plus 3. And that equals 0. Again, see it twice, write it once. And we have 3m plus 7 and m plus 3. And both of those need to be set equal to 0. And when we do that, we get two answers. We get m equals negative 7/3 and m equals 3. I'm sorry, negative 3, because when we subtract 3 from both sides on this one, it becomes a negative. Now, I had a lot of people do like subscripts, m1 and m2 equal these things. Let me show you what that looked like, because that was not very clear, I guess. M sub 1 equals negative 7/3. This is not quite right. So yeah, let's just leave it either as this form, m equals this. You can say m equals negative 7/3 and m equals negative 3. Or you could use the butterfly brackets that we saw last week. And that is the set notation. Okay. All right, let's scroll down to number 4. Number 4, this one has the 3x over here by itself, and that needs to be moved over to this side. And when we do that, we need to subtract. And so 17x minus 3x, that's going to leave us with positive 14x. So x squared plus 14x plus 49 equals 0. And if we had had some more time together, we would have really gone over, this pattern here. Two numbers that multiply to be 49 and add to be 14, that's 7 and 7. So here that would be, oh goodness, x plus 7 times x plus 7, or x plus 7 quantity squared, equals 0. And these two are exactly the same, so we would only need to set x plus 7 equal to 0 one time. And so our only answer here is 7. And that's one of those that touches the x-axis in only one place, if you recall from our video the other day. All right, last one. Obviously, this negative ADP comes over here. And I feel like I said something stupid again last week, like this one doesn't have a GCF. Of course it does. 5 goes into all of these. And it's very easy to get caught up with this lead coefficient here and say, oh yeah, 15 doesn't go into everything, so we don't have to take out a GCF. But it makes it incredibly weird if you don't take out the GCF. So here we go. When we put this ADP back to the other side, then we get 15p squared plus, that's not a plus, sorry, plus ADP plus 80 equals 0. And then there we can factor out the 5, and so we would get 5, 3p squared plus, I think I said 16p plus 16 I said. There we go, equals 0. And this is important to keep. I saw a couple people who just kind of knocked that off. You can't just get rid of the 5 because this is completely different than this right here. The roots are still the same, the solutions are still the same, and that's what we're looking at right now, but it is a bad practice to just willy-nilly drop the 5. And so that 5 is going to stay with us. And I need to have this in equation form because of the squares. All right, so two numbers that multiply to be 3 times 16 is 48, and add up to be 16, that is 12 and 4. So 3p squared plus 12p plus 4p plus 16 equals 0. And we would obviously group that and factor it. And I'm going to go ahead and skip that step because I want to keep this video short. It's going to be 3p plus 4 and p plus 4 equals 0. And yes, we have 3 pieces there. Each of them do need to be set equal to 0. Now, obviously, 5 is never going to be equal to 0, so that one is moot for the solution. But whenever we do other stuff with the lead coefficients or with the factors, it's going to be relevant. So please do not be in the habit of just knocking the 5 off. So when we solve these here, when we set each piece equal to 0, we get negative 4/3 and negative 4. Okay, and that's it for that. All right, well, we're going to move on to the next thing, and I will talk to you guys later. Bye-bye.